And now I'm sharing my screen on today's class. Okay, so we looked at the extra credit discussion today. We did the SOMA project presentations. We reviewed this quiz. Remember, the solutions are up above and lines on multi-views. And now we're going on to a term called pictorials. And if we go back up to the top of the class, remember there was one module that was called Engineering Drawing and Terminology. And actually, let's just go back and review that terminology because you probably know almost all of it now. ANSI standards, we mentioned, design versus manufacturing engineers, working drawings, documentation packages. We'll talk more about this when we get into our big design project. Bill of materials you already made, product, part, first product, lettering and sketching, multi-views, orthographic views, front, profile, side, and now we're talking about pictorials. Pictorials are three-dimensional, they're really three-dimensional drawings on a two-dimensional plane, or a three-dimensional representation on the two planes. And there are two different types of pictorial drawings. And you remember the first day of class, right? Was it in this class or was it in statics? God, I can't remember now. Let me look at you guys. Did you guys draw boxes, cubes, right? You drew cubes, right? That were isometrics and obliques. I only see Steve and Sunny, so I need to see some, yes, okay, thank you. Because we practice 3D drawing and statics as well. So obliques are the one where the front face is the true size, and then it shows the top and the side view off at a 45-degree angle and not true size. And there are two different types of obliques, but we'll talk about that in another class, not today. Because today we're going to be concentrating on drawing isometrics. All three sizes are true. The front side is on the left, the right side's on the right, and the top view's on top. And the front and the right side are both drawn at 30-degree angles from the horizontal line. I'm going to go back to our module now. I'm going to minimize this and open our class today. This is class 4, so I'm going to minimize that as well. I'm going to go to today. And now I'm going to show you some slides. Just to give you an example of the two different kinds. And I'm going to open this up. So first I'm given multi-views. What view is this? Everybody can unmute themselves so I can hear you. What is this? Front. How do I know this is the front?
Bottom left.
It's the bottom left and all other sides are drawn off the front. So this is the front view. This is the top view and this is the right side view. And on an isometric, they called it an axiometric, but it's an axiometric is there are many different kinds of axiometric. Isometric is the one we're going to be looking at. You can see that the front is here, the front view is here, and the right side view is here, and the top is here. So you've seen a lot of isometrics and then drawn multi-views of them, but now we're doing the opposite. I'm giving you multi-views and you have to draw isometrics. So take a look at this. What do we do? Well, we know that this line right here, this horizontal line, I could measure my 30 degrees off of to start my box. And you'll notice that there is a box drawn here for the front, a box drawn here for the side, and a box drawn here for the top view. And then I'm drawing the front side right on the front. So you see that it's added and it has a curve here, right? So I see the bottom, I see the top, and I see these straight lines. So I could draw this line, draw this line, draw this line, and draw this line. And then I see this goes up straight and then starts to curve. So I'm going to measure the distance up here, and then I'm going to start curving it over. And I basically could draw the whole front on the back plane too. And then on the right side, I see vertical planes, and there is a vertical plane here to start and a vertical plane here to start. But this vertical plane I see is pushed back more, because when I look at the top view, I see that that area there is cut off. So I basically am drawing this curve at 4 different places, starting on my front plane and moving back. So this is if I were to draw an isometric. And here's an example of what an oblique would look like. I am drawing exactly the same on the front, because when I draw an oblique, the front face, I'm looking at the front face in the front of my oblique. Basically, it takes practice just as much, in fact, maybe more practice than it takes doing multi-views. But I could take multi-views and draw these two. But today we're going to be concentrating on isometrics, but I'm just giving you an overview right now. So take a look at this box. They drew this front face on the isometric in the front, and they also drew it in the back as well. It's the same exact thing I'm drawing on the back, but I just wound up in the end erasing some lines. So here's another example. Here's an isometric drawing. I start out putting a horizontal line. I draw 30 degrees up and 30 degrees up, and I draw my front face bottom and my right side bottom. And I'm drawing it out. I'm drawing a line out the width. I'm drawing out the line, whatever the depth is, and drawing the height. So I'm starting to make the box, and in the end, here I have my box. This line and this line are 30 degrees up from the horizontal. And then this dimension right here is my width. This dimension is my depth, and this dimension is my height. And then looking at the picture, I'm able to measure the width of this piece and the width of this piece and put it on and use construction lines. These are the light lines. And then notice the lines were drawn dark to be visible. From the right, I see that this area is cut. So I measured this depth and measured the depth right here. And I knew that I just went up and I was able to cut this piece off. So this is the same as this. And then I draw visible lines to connect this right face with the left face in the back. And then from the front, I could have done it here. I see that there's a piece cut off, and I could have measured the height here and the width here that it was cut off. I measure the height and the width, and I cut this corner off both in that back plane and in the front plane. So what's really happening is when you're trying, you draw your whole cube, and then you start drawing things in the front, and you're drawing things as you're going back in parallel planes. Okay, now I'm giving you an isometric drawing, and now I'm producing an oblique. I know that this right here is my front face, and I know what my total width and my total height is of the body. So I draw a box that has the total width and the total height, and then I know what this height is here and what this height is here, and I know how far it's going back in width, and I'm basically cutting out, it's kind of like cutting out the front face from this front box. And then I also know what the diameter is of the two circles, and I know where the center of each circle is, so I'm able to draw them as well. And then I'm erasing my construction lines, and now I have my front face of what it looks like. And now I go back to my isometric and I can measure my depth. And notice this depth is all the same for this part. And so now I have to move your pictures. And now I start measuring the depth off here, the depth off here, the depth off here. And we know that it's 45 degrees. When it's an oblique, it's 45 degrees. They're showing you a range of 30 to 45 because there are other ways to draw, like architects might draw something different. But for obliques, we know it's 45 degrees. So at a 45-degree angle, I am going to draw in the line that shows all the depths and the depth here. And then I'm starting to connect the lines. In a way, I'm drawing the front face now on the back face, and then I connect the lines. It is intense. This is a new thing for many of you. Okay, I'm going to stop sharing for a moment.
I have a question.
Yeah, hang on. I'm going to remove my pen so I could see it, see all of you. Okay, who has a question?
Me, Tony.
Tony.
So how did you say we can tell that there is a sort of like a folding on the first figure that you showed, the first isometric?
Okay, so let's look back at that.
There's like a curve.
Okay, so in this picture here, I have to move the photos too. So notice the multi-view here doesn't show any dimensions, but on our homework assignment, you would have all the boxes, right? Or you could measure it and you would know what the dimensions are. Let's just say this is 2 boxes and this is 2 boxes. And it may be that going up is 2.5. They would tell you what the radius is here, so you would know where the center of this arc is. So if you know the height to the point, you would know the height to the point where, using math, where there's a tangent to the curve.
Okay, got it. Thank you.
Got it?
Yeah.
Okay, I'm going to stop sharing.